Hey guys, so originally I wanted to make one video covering everything about scientific notation, but it's way too much information to put in one video. So, this one I'm going to focus completely on multiplication and division, and then I'll make another video talking about comparing them, which is really just a division, just a division question. It's just kind of not obviously. So I'll talk about that specifically in my next one. So the first thing you need to know about multiplication is that the powers of 10 do not have to be the same. Originally, I accidentally put the word bases in my slide. I should have put powers of 10 because the base is just 10, and in scientific notation, it's always going to be 10, so the bases are always going to be the same, but the powers don't have to be the same, right? So this is a -9, and that's a -4. We're still allowed to multiply this together. On the other hand, with subtraction, the exponent, or the power, must be the same. So in order to do this subtraction problem in scientific notation, these tens must be the tens. If this was a -9 and a -4, we couldn't do it without converting these to standard notation. Okay, so just keep that in mind. It's a huge distinction. So, perfect. The other thing I want you to know about multiplication just in general is that you're allowed to mess around with the order of things. All right, so you all know that 5 times 2 is 10. 5 times 2 is 10. You all know that. And in the same way, 2 times 5 is also 10, right? But here's the cool thing. We can actually do this with multiple numbers. So I could 5 times 2 is 10 times 4 is 40. But in the same way, 2 times 5 is 10 times 4 is 40. I can also do 5 times 4 to get 20. 20 times 2 is 40. And I can also do 2 times 8. I'm sorry, 2 times 4 to get 8. 8 times 5 is 40. So here's the point. When you're multiplying a bunch of things together, changing the order does not change the product. Okay? Changing the order has no effect on the end outcome. So keeping that in mind, we can actually take this multiplication problem, right? So here's a number in scientific notation being multiplied by another number in scientific notation. So what we can actually do is play with the order. We can put the number here, that number there, and then our power of 10 next to our power of 10, right? So we haven't changed the product at all. Let me clear some of the stuff off now. So if we said that this multiplication problem equals, I don't know, z for whatever reason, changing the order, it's still equal to z. So we've changed nothing. You're also allowed to pick what you multiply first. So what if we multiply those together, and then we multiply those together? And this is the process you're kind of supposed to take. So that drops down. I grab my handy dandy calculator. 2 and 64 hundredths, or 0.64, times 4 and 4 tenths gives me 11.616, or 616 thousandths. So let me write that down. So we have 11.616. Now we just drop down the multiplication symbol from here. Right up here it's an asterisk. Here I'm using a capital X. And then we have to multiply those together. Now here's the cool thing. So the base, remember I talked about bases up here. Oops, the base is the number 10. When you're multiplying exponents, like we are, assuming the base is the same, right? So if we have x to the a times x to the b, right? So those are both x. That's just, maybe make that a That is x to the a plus b. So all we're doing is adding these together, as long as the base is the same. If the base is the same, add the exponents. Well, our base is 10, so we add these exponents. So -9 plus -4 gives us -13. Many people are going to be tempted to say, done, right? But you're not, actually. You're not done, because we don't like 2 digits on the left-hand side of the decimal. I have 2 digits. We only want 1. So the way we fix that is by extending this decimal over by 1. So that means that this is too small. It hasn't gone far enough. So if we're going further, we add plus 1. So the final answer should be 1.161 times, oh wait, I did that wrong. 1.1616, sorry, I messed up my 1s and my 6s, times 10 to the -12. Because -13 plus 1 is -12. You owe me $13, and then you give me $1. Now you only owe me 12. Okay, so this is our final answer. Now we're done. This was not the final answer because we had to keep it going. So I want you to try this. So I actually want you to pause the video. I had a little symbol over here to say pause, but I accidentally deleted it. So I'll just say, let me draw the little pause button. There we go. Okay, so go ahead and pause the video now and work this out. Okay, so hopefully you did that. If you actually pause, if you actually work these out, you're gonna learn more. So hopefully you did that. If you didn't, do it now. Trust me, it's worth it. Okay, so hopefully you did some reordering. Hopefully you said 3 2/10 times 1 1/10 times 10 to the 6. Oh, that's number 8. Times 10 to the 6. I'm going to add that exponent here in a second. Times 10 to the 7. So now let me add in my exponent 6 and my exponent 7. Again, let's multiply those, and then we'll multiply these, and we'll just drop down our multiplication symbol. 3 times 2, or 3.2 times 1.1 gives us 3.52, or 3 52/100ths. This over here, the base is the same, the base is the number 10, so we add the powers, or the exponents. 6 plus 7 is 13. So it's times 10 to the 13, and that's it. We're done. Not too bad, right? Pretty easy. Pretty easy. Let's do one more. Again, let me draw my little pause button. So go ahead and pause the video now and work this out. Okay, hopefully you did that. And hopefully you also did some reordering. I'm not going to show all of the work here, but hopefully what you did was 3.2 times 2.1 to get 6.72, or 6 72/100ths. Drop down that multiplication symbol, times 10 to the 6 plus 7 is 13 again. And that's the final answer, right? Not too hard. Now, if, let's say hypothetically, instead of 6.72, what if we, I don't know, did something crazy and got 67.2? Well, then we need to bump this over by adding 1. So then it'd be to the 14. So don't forget, make sure you only have one digit. In this example we did. That was pretty handy. Division actually isn't all that hard either. What you can do is rewrite the division problem by breaking this up. So if this is the division problem, 6 and 5/10 times 10 to the negative 6 divided by 3 and 25/100 times 10 to the 4, well, you can rewrite that to look more like this, okay? So we're basically just breaking it apart. Remember when you multiply fractions, you just go across the top? So these two things are equal to each other, because if we did 6.5 times 10 to the negative 6, well, that's just that. So break them apart, right? Like a big old earthquake came and just shattered it. And then in the exact same way that we just did the actual multiplication and then work that out, we do the same thing here. So we divide this, drop down the multiplication symbol, and then divide that. Let's see what we get. 6.5 divided by 3.25 gives us exactly 2. So it's 2 times 10 to the, now in multiplication we added. We said 6 plus 7. In division you subtract. So it's going to be negative 6 minus 4, which I like to rewrite as negative 6 plus negative 4. You're allowed to do that because these are equal to each other, and that gives me negative 10. This is easier for me to work with. If your brain works with this, awesome. Just keep it like that. My brain wants me to change that to adding, because this is easier for me to visualize. So that's it. That is the answer so far. Now, if we were simplifying all the way, we would then want to do 1 over 2 times 10 to the positive 10. Remember, because a negative exponent turns this whole thing into a fraction. But for the sake of what we're doing, I'm not overly concerned with that at this point in time. This is the final answer that I would want you to get to for now. Okay, because you should all be pretty comfortable with then simplifying this down. I want you to try this one. So let me encourage you to go ahead and pause the video, and then we'll work this out together. Okay, again, hopefully you paused, because if you did, you're gonna actually learn something. So we're gonna pretend a big old earthquake came, broke that in half, and so then we have 6.8 divided by 3.2 times 10 to the negative 6 over 10 to the 4. So then we do that division, we drop that down, and then we do that division. So let me pull up a calculator. 6 and 8/10 divided by 3 and 2/10 gives me 2.125, or 2 and 125 thousandths. So 2.125 times negative 6 minus 4, right? It's the exact same thing we just did over here. Negative 6 minus 4 to get negative 10. So times 10 to the negative 10. Hopefully you got the answer. If you didn't, hopefully you see why. Let's try this one more time. So go ahead and pause this and work it out. Okay, so for time's sake, I'm not going to draw all this out, but hopefully what you did was 4.16 divided by 5.2 to give you 0.8. So 0.8 times 10 to the negative 6 minus negative 4 is the same thing as negative 6 plus 4, which gives us negative 2. Negative 2, but we have to move that over by subtracting another 1. So 8 times 10 to the negative 3 should have been your final answer. Hopefully you guys were able to do this successfully. Thank you for watching. Have a good day.